Hello everybody and good day. This here is the UOG's AR Sandbox. Today we're using the Sandbox to simulate a catchment basin, which is any area of land where precipitation collects and drains off into a common outlet. The sand in the box represents the topography of the area that we are interested in. This could be a section of Manila, Santa Rita, or any place really. As long as we know the topography of the area of interest, we can model it here in the Sandbox. As you can see, well, we can't look up right now, but the projector that's above us captures the image of the topography in the Sandbox. The different colors that you see and the contour lines represent the change in the elevation over the area. Once we have set up the topography how we like, we can rain down on the terrain to see a representation of how the rainfall runoff would flow over the terrain. So here I can use my hand to make it rain over this area. And as you can see, the rain is running off the hillside. See right there. Once we have set all that up, we can visually see how fast the runoff flows over certain parts of the terrain where the outlets are located. Here, around here is where the sink is, as well as where the water tends to collect and pools in certain areas. It's pooling here and it's pooling here because of the way the terrain is shaped. A good purpose of this Sandbox could be used for city planning and assessing potential flood zones. Here I set up a demonstration. In our demonstration, we have potential sites to expand suburban housing in this undeveloped area of land. Here we have a site down here in the valley and another site up here on higher terrain. Okay, I just flooded that. Ignore that. As I cause a heavy rain up here high on the mountains, the runoff races down to the nearest outlet in this watershed, so I'm going to make it flood. Look at all that rain. As you can see, the water is racing down towards the lower side and flooding it heavily. The speed of the water and the quantity could severely damage this site, and that will put lives at risk. We need to consider potential mitigation if we want to build on this site down here, such as altering the grade, which would be very costly to move the earth around, or we could build structures to deflect the water. Like here, I could do this and it will redirect the water around an alternate flow path. Or, since the water likes to collect up here, I could also build a dam to stop the water from flowing down into this little village. There we go, make it rain. Come on. Okay, there it's raining. As you can see, the water is pulling up here and the dam is holding it back. As well as if I make it rain down here, this wall that I built is helping to protect that little village by redirecting the water down an alternate flow path. But we need to consider the cost of these possible mitigation options. If the cost outweighs the benefits, then we would just abandon this site altogether. And as you can see here on the higher site, the water flows more slowly as it washes through the site. And it drains out of the site much easier. But there's still possibility of flooding and erosion up here on this higher site, which is still a concern. But it appears that this site up here would be easier to mitigate than the lower site. Nonetheless, that is a decision that we need to make upon further analysis of the costs and benefits of building here. Okay, thank you everyone. That is my demonstration for today. The end.